Good afternoon, everyone, and welcome back to Clay Loves Logic, where on this channel I solve logic-based Sudoku puzzles I find interesting. Today, I'm going to be looking at the puzzle Getting Hooked on Math by H. Bell. I only have about 25 minutes today, so I gave this one a look. I think I'm going to be able to solve it pretty quick, but let's get into it. Normal Sudoku rules apply. You have to have the digits 1 to 9 in every 3x3 box in every row, and indeed in every column. Palindrome lines. The gray line's a palindrome, meaning it can be read the same from either direction. So if this is a 6, this is a 6. If this is a 9, this is a 9, etc. Killer cages. Digits in a cage must sum to their number given at the top left of the cage. So this sums to 15, this sums to 15, this sums to 8, this sums to 13, etc. Black Kropke dots, digits separated by a black dot are in a 1 to 2 ratio, 1, 2, 2, 4, 3, 6, 4, 8, anything like that. Not all valid clues are given. That is what we get, and we are meant to solve the puzzle. So let's get into it. We have a 6, 7, 8, 9 quadruple in the first box by way of two 15 cages. You can make 15 two ways, 6, 9, or 7, 8. These two are on the palindrome, which means these two are also from 6, 7, 8, and 9. So next we can say a 10 cage. Look at that. A 10 cage with 4 digits has to be 1, 2, 3, and 4, doesn't it? 4 plus 3 is 7, plus 2 plus 1 is 10. And 3 of them are on there, and it's 1, 2, 3. So all of these are on the palindrome, to nobody's surprise. Sorry, 1 second. I have to respond to this. Terribly sorry. Almost done. I have some plans tonight, and someone was just asking about them, so I had to get to them. Okay, so if this is a 1, 2, 3, 4 that's in a 10 cage, then this is a 1, 2, 3, 4. It's the same digit. This is in a 12 cage, so this can't be 1 or 2, right? Because it's 2 digits. So if this is a 1 or a 2, you'd have to have 10 or 11 on this, which you just simply can't have. So this is from 8 and 9. 1, 2, 3, 4. 1, 2, 3, 4. This is also from 8 and 9. A 7, 8, 9 cage is interesting because it can only be 7, 8, 9, or a 24 cage. A 24 cage has to be from 7, 8, 9. That's the only things it can sum to, right? Because 7 plus 8 is 15, plus 9 is 24, which makes the first two digits of this palindrome and the last two digits of this palindrome a 7, 8, 9, which means there's always a 6 here. And that is going to be able to tell us that this is a 6, 9 pair because these two are on these two, which is a 15. They're the same digit. So we have a 6, 9, and we have a 7, 8, which is going to give us our first digit, isn't it? Because this sees 7 and 8, and this can't be 6. This can only be 9. So this is 6, and this is 9. And by way of palindromage, this is 9, and this is 6, which makes this an 8, and this an 8, which makes this a 4, and it makes this a 4. And now none of these are 4. We have a 1, 2, 3 triple, and that's the first 3 lines of the palindrome, which means this is the only one that could be a 4. So none of these are 4. This is a 1, 2, 3 pair, and it's just going to have to be 3 and 6, isn't it? Because if it's 1 or 2, it's going to require it to be 2 or 4, and we have a 1, 2, 3 triple. So this is now 6. This is 3. We have a 1, 2 pair here. The first digit of the palindrome is a 3. This is now a 1, 2 pair, as we can see by dint of palindrome. So neither of these are 9. We have a 7, 8 pair, and now we have a naked single, and it's going to be 5, isn't it? This is a 5, and this is a 5. Okay, and obviously neither of these are 9 anymore via this 9, and this puzzle is really moving. So we have to make 14. I think there's going to be a few different ways we can do that, isn't there? Because this cage sums to 20, and we can already see 6 of it. So if we have a high digit, well, sorry, of the combinations that are high, we could have a 9 and 5, both of which are valid with no constraint. And we can have an 8 and 4, but that's only going to work. Actually, 8 and 4 doesn't work because this digit here sees a 4 and an 8. So neither of these are 4 or 8. So that is, in fact, a 5, 9 pair. That's going to give us a few digits left. 1, 2, 3. We're going to need a 4 somewhere down here, which is not on the palindrome, is it? Because if this is a 4, this is a 4. Actually, this could be a 4. This one, this couldn't be a 4 because it would make this be a 4, and there's already a 4 in this box. So in fact, the 4 is over here. And that's going to give us 1, 2, 3, 4, 5, 6, 7, and 8. So this is an 8 because there's an 8 seeing these. An 8 there puts an 8 here. And we have a 7, 8, or a 7, 4 pair. Okay, what, I ask you, should we look at next? And that is a good question. Let's have a look quickly. Sorry. All right. Where do we go from here? What do we need? We need heaps of things, but that's not terribly interesting. Let's look at this 13 cage. That's going to be interesting, isn't it? A 13 cage is going to require some high digits. 6 and 7 possible only if it's 6, 7. And this is the middle of the palindrome, so neither of these are repeated. 6, 7 works in that case. The next way you could do it would be 5, 8, which just never works because there's a 5, 8 in all of these. I mean, there's, you know, a 5 and an 8 here and a 5. There's no combination with which we could put 5, 8. The other way you can make 13 is with 9 and 4. There's 9 in both of these. So in fact, this just has to be 6 and 7. It's the only options available. Oh, and of course, this 8 sees this 7, which sees this 8. Okay. So now we're going to need an 8, which is naked by this 8 and this 8 and this 8 and this 8. So we need the digits 1, 2, 3, and 4 in the top row. Which means we need the digits 1, 2, 3, 4 in here. And that's going to give us a 4. Because we can't have a 4 in either of these positions because of this 4 and this 4. So 4 is removed, 4 is removed, and then 3 is removed from this one, which removes 3 from this one. And that's not a 4. So we have a 1, 2, 3 triple and a 1, 2, 3 triple. And the combination of digits on the bottom of this now is going to be 4, 5, and 9. Is it not? Yes, and that is going to be a naked single. That's a 4. This is a 5, 9 pair. Is this 4 the central digit of the Sudoku? Or the palindrome. 7, 8, and 7, 8. Then there's going to be this digit, and then 8. Yeah, so the 4 is the central. Doesn't repeat. Okay, sure. What's next? Well, what digits do we need here? Oh, well, better question is, where do we put a 4? Only there. Can't be here or here. So what do we need down here then? We need some combination of 1, 2, 3, and 7, I guess. So 1, 2, 3, 7. That's going to make this one a 1, 2, 3, 7. And it can't be 3 because of this 3. So this can't be 3. So 3's over here, which means there's a 3 somewhere here. If the 3's here, it's here, which would force the 3 to be down here, wouldn't it? Yeah, so this is not the 3. In fact, the 3 is always in this central box. The 3 is always in this box, which means in here, the 3 is in one of these positions. If the 3's here, then it's here, and that's the same problem. We need a 3 up here. So these two could be 3, which gives us a 3 there is fine. Otherwise, this is a 3 and this is a 3, and it gives us a 3 there, which is fine. Okay, sure. Let's look up here. What do we need? We need 1, 2, 3. Lots of 1, 2, 3 triplage going on. A 1, 2, 3 is going to give us a 7, a 6, or a 5, isn't it? Because we need to sum to 8. 7, 6, 5. Those are the options. Can't be 5, and it can't be 7. So this is a 6, which goes with a 2. 2 is now removed from here. And that is going to, well, it forces a 2 down here. So neither of these can be it. Oh, wait, sorry. No, it takes the 2 out of there. My goodness, almost got ahead of myself. Almost made a very silly error. What it does do is it does, in fact, force a 2 on the palindrome, doesn't it? It does, of course, because we have to put 2's in these rows. Okay, and now this can't be a 2 anymore. This is a 1, 7 pair in whatever way it decides to work. Okay, what's next? Maybe we should look at this 12 cage because a lot of the high digits are gone, 6, 7, 8, and 9. So it certainly has to have a 4, doesn't it? In fact, I think it has to be maxed at 4, 5, and 3. That's the only way you can make 12. 5, 6, 7, 8, 9, 10, 11, 12. Yeah. And then this is a 5 because it sees a 4 and a 3. Now, neither of these are 5. And this can't be a 3 because of this 3. So, in fact, we're going to get a 4 and we're going to get a 3. This 4 is going to see this 7. There's one in the corner, which is going to give us a 4 as the central digit of the Sudoku. This is a 9 because it sees this 5. This is a 5 because there's a 9 in the cage. And what is that going to tell us now? Well, one of these is 5. Okay, this is a 1-2 pair, is it not? It is. What do we need here now? We have a 9 cage, and it can't be 5-4. It can't be 3-6. So what other options do we have? 1-8 and 2-7. And if it's a 1-8, this is not the 8, so this is not the 1. And if it's a 2-7, oh, and there's a 1-2 pair here. So if this is the 2, this is the 7. And we have a 1-3 pair here. So in fact, this is a 2, and this is a 7, which makes this an 8, and it makes this a 7. And then on the other side of the palindrome, we get an 8-7. Excellent. Now we need a 7 somewhere in this middle box. And if this is the 7, this is the 7, and that breaks the Sudoku because we already have a 7 in that box. So these are both 7s. And we have 1-3 pairs, we have 5-9 pairs, we have 1-2-3 triples, we have all sorts of fun things. This is a naked single, isn't it? It's an 8. Yes, excellent. Oh, and this 2 sees the 1, sees the 2. So that does the 1 and the 2. That does the 3. The 3. Now we have a 1-2 pair, so it gives us a 3-1-3. And that is going to, oh, this 1 gives us a 2, gives us a 1. Coming from the 5, it goes 1-2. Now we're going to need 1-2 that doesn't resolve yet. What else do we need in here? We need 1, 2, 3, 4, 5, don't we? This is a 3 because there's a 4 and 5. So this is 4, 5. This 4 sees it. So this is a 5. This is a 4. Down here's a naked single, and it's going to be a 6. What's remaining? We need a 1, which has to go here. 1, 2, 3, 4, 5, 6, 7, 8. So this is a 9. This is now 1, 2, 3, 4, 5. This is a 6. And the combination of digits we need down here is going to be from 1, 2, 3, 4. We need a 5 that can be anywhere somehow. That's interesting. 7 and 9, don't we? Wow. And by this 7 and this 7, 7's in the middle at least. Wow, do we really not have a 5 or a 9 placed in the center? We don't. That's wildly interesting. Okay. What goes here now? We need the digits 1. We need a 2 somewhere. Not here because of this 2. Oh, so that's a 2-3 pair. And so 1, 2, 3, 4, 5, 6. This is now a 9, which gives us a 9 here. And now this combination of digits has to be from 1. Possibly 1, 2, 3, 4, 5, and 6, doesn't it? Can this be a okay, well, now we know this can't be a 3. So this is in fact the 3. The 3 does the 2 does the 3. This is a 1 or a 5. Oh, but look, this was only 5 or 9. So this is the 9, or this, sorry, this is the 5. This is the 9. This is now a 1, which makes this a 1. This is a 6 by this 5. This is a 5. This 5-9 pair is solved by this 9 down here. Okay, so this is a 2 because of this 1. This is a 1. And remaining in the grid, 1, 2. And down here, 1, we need 1. We need 1, 2, 3, 4. We need 5 and 6. This is a 6. This is a 5. 13 minutes, 56 seconds. 923 people have solved in 6.3 days. I did like that puzzle. H. Bell, getting hooked on math. That's a great puzzle. I had a great time, and I hope you enjoyed the quicker video. Thanks, everyone, and we will catch you on the next one.